So let's see a proof constructed all the way through. So here we're given the measure of angle AOI is equal to the measure of EOU. So I'm going to start with that as my first statement. All right, and so I'm going to write that into my diagram. The measure of AOI is congruent to the measure of EOU. And our reason there is that's a given. Okay. All right, and so next, and remember, like, our destination is this, right? We want to end up with measure of angle 1 equals the measure of angle 3. Okay, so we know that's going to be our last statement. So the first thing I see here is that angle AOI is composed of 2 units, right? Or excuse me, 2 angles. And so I can use the angle addition postulate there. So I can say for my second statement that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle AOI. Okay, and the reason why is because of the angle addition postulate. All right. So in the same way, I can say that angle 3 plus angle 2 equals angle EOU, right? With the same postulate. So I'm just going to keep that as my second statement. Measure of angle 3 plus the measure of angle 2 is equal to the measure of angle EOU by the same postulate, right? So I'll just keep that as one statement. All right, so now what I see is I have 2 values that are equal to each other, right? AOI and EOU, so they have the same value and they're equal to 2 different things. And so that means those 2 other things must be equal to each other by the transitive property. Okay, so I can say now that the measure of angle 1 plus the measure of angle 2, this value here, is equal to this value, the measure of angle 3 plus the measure of angle 2, right? And that's by the transitive property. Right? Two things that equal the same value are equal to each other. All right, so now that we know that's true, I see that measure of angle 2 is the same on both sides, right? I'm adding it to both sides. So I know that, and this is kind of the obvious one, but once again, we use it a lot. So the measure of angle 2 is equal to itself, right? And that's because of the reflexive property. All right. So measure of angle 2 is equal to itself. All right, and then we can subtract the measure of angle 2 away from both sides, right? Which would give us what we want to end up with, right? And so we can do that by the subtraction property of equality. So I can say, okay, well, we have enough information to conclude that measure of angle 1 is equal to the measure of angle 3. And the way we did that last step is by the subtraction property of equality. All right, so we did it. So once you get to that, once that matches that, then you're in the right place. Okay, and I think, you know, one of the challenges with proofs is just, you know, how do I get to the next step and to the next step and to the next step? And so just try to think about, hey, what do I know that's true about what we have here, right? What we're given and what we can tell by the diagram and so forth and so on. And so, you know, and hopefully you kind of make your way there, but you want to think about, okay, is this going to help me to reach that final goal? Because, you know, there might be other things that we know are true, but you want to kind of have you know, your destination point in mind as you're going through. So, you know, it's definitely a skill that you'll get better and better at and you'll figure this out more and more as you practice. All right, so here's one that we're given uh, a few statements and a few reasons, and we're asked to fill in some of the blanks, right? So what we're given is that KP equals ST, so the length KP is equal to length ST. Remember, if you don't have a bar over, we're not talking about the segment itself, we're talking about the length of the segment. All right, and we're trying to prove that KR equals SV. So if you actually want to put that at the end, you know that's where we want to end up, right? Okay. So, so it's our first statement we're going to put in our givens, right? And then tells us our reasons. Our reason is given. So we're just going to put those in there. KP equals ST, right? These two are congruent. And we also know that PR is equal to TV, as those are also given. Okay. Statement 2, KP plus PR equals ST plus TV. Okay, so in other words, we're starting with this equation here, okay, KP equals ST, and we're adding equal value on both sides, right? We're adding PR and TV to each side, which they're equal value, okay? So if we add the same value to both sides, but still hold the equality, that's the addition property of equality, right? Okay. So the next thing they're saying is KP plus PR. So KP plus PR equals KR. So KP plus PR equals KR. So that's the segment addition postulate. Good job. So segment addition postulate. And then they did the same thing with ST and TV equaling SV, right? So that's also the segment addition postulate. So we have that. All right, so now we know that KP plus PR is equal to ST plus TV, right? So therefore they must be equal to each other, right? And so in the last example, we used the transitive property. Here they're using the substitution property, which, you know, to me, I think you could go either way with that. I would take either one, because we're saying here that we could substitute this in for this, right? And then we have those two things that are equal value, so so they must be equal to each other, right? So, but I think that's also the transitive property. So I think you can go either way with that, and I would take either one for full credit. So, so we can say that KR, equals SV, and we can say that by substitution or the transitive property. Okay. All right, and we got to our end result. So one of the things that is nice about proofs is you always know what you want to end up with, right? You know what your answer is. You just have to figure out how to get there. So it's kind of like a puzzle, and hopefully you enjoy it as much as I do.